I got to get my page up here. I want to start with our Weather Watch satellite page. So let me get that going here.
Welcome everybody. There in the lower right-hand corner, there should be, if you click on that little purple arrow, you'll get a menu that comes out, and there's a chat on the lower left of that. If you have any questions or comments, go ahead and post them in there, and I'll monitor that and pass them along.
What the heck is going on here, Pete? Oh, there we go. Okay. I didn't load in this satellite, so I'm going to do it now. It'll be the goes east North America. Okay, I'm going to share my screen as it's coming up.
Okay.
Well, let's see. I just did that, but it doesn't seem to have caught on. Why is that?
I don't know.
I am a moderator. I see that.
You are a moderator. You should be able
I'm
to
hitting share application screen.
There we go.
Oh, there it goes. Looks like it finally went on now. So maybe you can see my screen now. Okay. Well, welcome to the weather discussion, everybody. It's Michael mentioned in the prelude, if you heard, we were talking a little bit. It looks like it's a relatively boring period of time coming up, although there are some interesting things to talk about nonetheless. And I'm sorry I didn't have this loaded ahead of time, and my internet connection. Everybody's at home, not because that works. It takes a while to come in. What we're looking at is the satellite, infrared satellite movie over the last 12 hours, continental and adjacent waters. And we have a couple of features of interest to talk about today, I think, in the near vicinity of the country. One of them is a storm that really got itself nicely organized, put together rather quickly on Wednesday. And that's, we'll see when this finally decides to fill it all in, we'll see that's the storm that's crashing onto the coast of New England. It's an odd east to west movement. Reminds me a little bit of Hurricane Sandy and also the perfect storm from 1991, but at a particularly different longitude there. But it's got an interesting evolution. The storm that you can see here crash to the New England coast, moving from east to west, and it started off Carolina coast on Wednesday, a rather dramatic development actually, and then sped northeast.
There's a bit of a lag here, John. We're not, or at least I'm not seeing your.
Sweet time. Not seeing my screen yet?
I see your screen, but it's still on the loading images page.
Yeah, it should be about done now. Is it coming on now?
Okay. Not yet. Your connection seems a little glitchier than previous times.
Oh, I'm not sure why. Okay. Well, I'll go downstairs and see if it's better. Hold on.
The joys of online learning.
Yeah, oh yeah, we're learning everything about how to do it, but we're not learning anything about the science. It's frustrating. It's kind of the nature of this beast, I'm afraid.
Right.
Every day that I post my lecture, I tape it in several different pieces, and then I post it. It takes an hour to get onto Canvas. It's just outrageous because everybody's doing it at the same time, I suppose. So is this a little better? I'm closer to my router. I hope that's better.
Your voice and your video, yeah, I think that's probably going to be better. It looks like it's ready to go now.
Okay.
I do see a satellite in the background, so go ahead.
Okay, so it's a storm of interest that's kind of, as I said, moving east to west across the Cape Cod and the islands of Massachusetts. And it's been a kind of a rainy, stormy day in the eastern United States, well, the northeastern United States today. Then we can see some really vivid transformation of the surface temperature early in the morning here in a 12-hour movie. You can see it's kind of cold over the land, and then suddenly it's a lot warmer over land than over the ocean. The ocean temperature is not changing at all. And so it's a dramatic impact of the daytime insolation particularly nice because it's uncloudy in that portion of the eastern United States. And then we've got low clouds and precipitation and scattered on some of the central plains, although it starts to look like it's a little bit more organized as the morning has worn on across Iowa and then across the Missouri-Kansas border and into Oklahoma and Arkansas. And we'll see a reason for that in just a minute.
Hey, John.
And in the western
We
United
just
States,
lost your screen. You might want to try and re-share your screen again.
Okay.
Somehow it dropped off.
Yeah, okay.
It wasn't moving real smoothly either at that point.
Should be back now, right?
Yep. Let's see if that's.
Is that working now?
Yeah, much better.
Okay, yeah, sorry about that. And then the western United States, clear as a bell over much of that portion of the country. You can see the low clouds across Texas and maybe far southeastern New Mexico, indicated again by daytime heating of the non-cloudy locations just to the west of that. So this situation here in the central part of the country where the cursor is doesn't really look particularly interesting or well organized, although there is something underlying it that's quite interesting, and we'll talk about that as we move forward. Okay, so I want to go next to the radar summary across the continental U.S. Here we go. And I'm not going to go to the West Coast satellite because it's not that interesting and it's going to take too long to load, so I'll leave that alone today. But here you can see the precipitation's moving onshore, and here's the sort of western edge of the circulation center, I think, that's just south of Nantucket. And you can see that kind of racing to the west. Very interesting. And then here's the precipitation. It's becoming a little bit more widespread and seemingly better organized all the way from La Crosse area all the way down to south of Kansas City, almost into northern Oklahoma. And then there's a seemingly not related piece of precipitation gradually traipsing its way across Arkansas. The western half of the country just about precipitation free, and it was almost cloud free as well. So it's kind of interesting to see what's happening here around the rest of the country, temperature and dew point wise. Quite an interesting day. So let me go now to our surface analyses. Let's see, surface observation. Let's look at the big map. And then let's take a look over the eastern United States. I wish the zoom wasn't quite so big when you zoom in. It just goes from nothing to everything. But let's go down to the southeast United States and take a look at some of these temperatures and dew points. Earlier this week, I think it was this week, Monday, we had dew points in the 60s and 70s along the Gulf Coast, and that warm, moist air has been flushed out. So you can see widespread dew points in the mid-40s. Not a bad day in Atlanta. 71 over 41 is pretty nice for them. And dew points are nowhere over 60 except a couple of spots, maybe in Louisiana, everywhere from the river to the east to the coast. So a pretty nice day in the southeastern United States. You can see clear skies prevail, temperatures in the low 70s, dew points in the low to mid 40s. It gets more moist as you move towards central Texas, where dew points are in the mid to high 60s. And but there's some substantial gradients of dew point and wind shifts. Look at this. 44 degrees with light rain over 44 dew point at Dallas, 66 further to the east near Texarkana, 59 dew point. So with southeasterly winds everywhere along the coast and somewhat inland, and then suddenly northerly winds, strong ones, 20 knot northerly winds everywhere. In a minute, I'll show you some observations of this frontal passage through Oklahoma, through the mesonet, which is going to be kind of interesting to look at. But you can even see it in action in other places. It's look at this freezing rain to the west of Kansas City. Is that it's the city for the University of Kansas? I can't remember now off the top of my head. Lawrence. So it's cold and dry. Look at the dew points in the 20s, and then 37 over 33 to the west of Joplin, 62 over 56 near Dollyville or whatever it is there in northern Arkansas. So pretty unbelievable cold front. And you can see it all the way across our own region. We had 63 over 45 at Rockford, 59, 41 over Madison, and freezing rain in Rochester, ice pellets in Minneapolis. Temperatures are in the 20s. Here it comes. That little bit of spring we had yesterday is over for the time being. And it's going to be somewhat dramatically over as this front comes by. The temperatures will drop really quickly across the region later today. I'm guessing late in the afternoon today will probably be when we start to see that happen. Okay, so that's going to be Pretty interesting situation. Now, let's take a look at our upper level charts. Go right here and start at 500 millibars with the superpeat, of course. And here's our 12Z surface, a 500 millibar analyses. And you can see some of the features of interest that are driving some of this dramatic weather across the continent. This is really a cold upper low. Look at how cold it is in central Alberta. It's minus 40 analyzed, but the coldest is near Calgary at minus 39. That's the actual observation of minus 39 at 500 millibars on April 3rd. And so that's pretty cold and a pretty intense baroclinic zone that rings this upper trough. So you can see all the way from, well northwest of Lake Winnipeg down into the Boulder, Denver area. There's a strong 500 millibar temperature contrast. No place warmer than about minus 20 at 500 millibars. So that's really cold. There are surface temperatures, I should have shown you this, in Montana, surface temperatures this morning were around 0 degrees at some of the mid-elevation stations in the western part of the state, and then even some low single digits in the plains of Montana. So this is a really cold air mass, and yet we're sitting here just now with the ridge axis, and it's a kind of a flat ridge axis to our east. I think the high clouds are beginning to invade as a consequence. We had a beautiful day on this side of the ridge yesterday with light winds and temperatures, in the mid 60s. So a beautiful day for us yesterday. Here's the cutoff low off the east coast of the United States, and you can see the winds are pretty intense, 45 knots here at Halifax and at 500 millibars. And this is a low-level disturbance, it looks like to me, not really an intense upper disturbance. So a curious weather system that is now really guided by strong east to west flow at about the latitude of its center of circulation. I'm not sure, I haven't seen yet what it looks like at 300 millibars this morning in that location. Yeah, fairly featureless. Isn't that remarkable? This is just a broad upper trough. The main jet is a subtropical jet, it seems to be, with a little bit of intensity off the coast, but there's really nothing going on at the latitude of that storm. So that's very interesting. Yes.
Yeah, I was going to just make a note of it, that it'd be interesting to look at lower levels of the atmosphere. But one of the interesting aspects of this storm, I think it was that disturbance that was tracking across about 2 weeks ago, was forecast to track across northern Texas, the northern Gulf of Mexico, and then exit the southeast coast, and then intensify rapidly just off of Cape Hatteras. And maybe that's actually what occurred. I haven't tracked it carefully this week. But the interesting thing was yesterday or the day before, there was actually a 40% chance that it might transition into a subtropical cyclone. So there may be some evidence that from what you've just shown, that this might have some warm core characteristics, meaning that it's going to be dynamically kind of centered near the lower troposphere as opposed to controlled by an upper feature.
Yeah, that's all consistent with the way this thing seems to have behaved from Wednesday till today in a lot of ways. I saw some close-up satellite imagery, should have saved it on Thursday, of the intense development at the core. I think you showed me that, Michael, didn't you? Where the subsidence region was so clearly cloud-free, so it was really intense subsidence, and then just off to the east was really intense convective development. So it had elements of what looked like synoptic scale forcing elements, but mesoscale convective manifestations of those elements that really probably made it a hybrid. And now to see it moving from east to west so dramatically and so obviously really makes me wonder if you're not exactly right about that. So that's curious, isn't it? April 3rd, unbelievable. So it's really interesting. We'll go down lower and see in a minute. And then you can see a weak flow around this cold upper low at 300 millibars. It's struggling to get over 100 knots. So that's right here in northern Alberta, Manitoba. So kind of a interesting flow at 300. Let's try 250 before we go down lower. And I think that makes it more obvious that what we've got at this quadrant of the hemisphere is just almost a zonal subtropical jet all the way from somewhere in the eastern subtropical Pacific across the lower states of our own country and then barely curving northward as it moves out over the central Atlantic. So a really dramatic and lengthy subtropical jet feature. Most likely it won't last like this. It's going to break up into waves. I presume the subtropical jet is not immune to baroclinic instability any more than any other jet is. But it's bound to start rippling into waves, and when that happens, the flow gets interesting in lots of other places. So we'll keep our eye on that for the week that's coming up. not here, but in other locations. Let's go down to 700 millibars first. And that flow at 700, that's a much more intense disturbance at 700 millibars, in keeping exactly, Michael, with the notion that this is a lower tropospheric disturbance that weakens with increased elevation and probably is a bit of a warm core. There's a little analysis there of some isotherm. I can't really tell what it might be. Maybe it's 0 and this is -5, but I don't trust that. It's a little bit too small to really put much faith in that. We'll see what it looks like at 850. But here's our baroclinic zone associated with the fairly sharp cold front that we saw at the surface in Texas, Oklahoma, parts of the south central plains. So this thing is sloping back into the west, upwards and northward and westward with height, as would be the case with a classical cold frontal structure. And let's see what it looks like at 850. At 850, it's a little more obviously got a little bit of a cut. The disturbance on the East Coast has an obvious cutoff isotherm. I can't tell what the value is. It's +4 at Provincetown and 0 at New York City, 0 at Albany, 0 at Halifax. So it is warm core right in the middle of that thing at 850. I don't think I'm missing a -4, right? And that's +4. So that's a warm core disturbance in the lower troposphere right off the east coast of the state. So there's something very curious about that storm. And remember, this whole disturbance is poleward of the jet that drapes right across the southern part of the continent in the upper troposphere. So it has nothing to do with the jet, at least not very directly. And then here's the 850 temperature contrast associated with the cold front that's racing through the plains, and that's dramatic. Look at this, 180-degree wind shift between Kansas City and Goodland, Texas, 15-degree temperature contrast. This is really quite a dramatic frontal feature, even in the lower troposphere, let alone at the surface. And I want to show you a few things about the at the surface point of that right now. Okay, so that's kind of some interesting observations that are shaping up for this storm. So let me show you from the Oklahoma mesonet this morning, in case some of you might be unfamiliar with this. Oklahoma long ago invested in this mesonet of surface observations, really high resolution in time and space, as you can see, the space part. And they're all across the state. And I'm going to show you a selection of observations over the last 24 hours. And Michael, you'll see this. These are called meteograms on the
That's what they call them in Oklahoma. We here call them meteorograms.
You'll see vivid evidence of that in just a minute. So here are the 6. I'm going to take 6 stations at random, but not really at random. They're kind of widely distributed across the state to just show you what's going on across the state. So the first one of those is called Mangum, and that's in the far southwestern part of the state. And this is what Mangum, and there it is, the Mangum 24-hour mesonet meteogram, as you can see right there. This is from 12Z yesterday to 12Z this morning, and the green is the dew point temperature and red is the temperature. So we are watching this data in a time series over a day, and right about 23Z, there's a dramatic drop in the temperature. It goes from about, I can't really read it off the there exactly, but it's about high 60s down to about 50. So something on the order of 10 to 15 degrees in really a matter of minutes. And you can see the wind direction here underneath in yellow, southerly, and then gradually getting a little easterly, and then suddenly it's northerly right about at that point where the temperature drop occurs. There's a little bit of interesting stuff going on here because the wind direction flips over itself on the scale. And the dew point temperature drops quite dramatically as well. So there's a classic cold frontal passage at the surface. Very sharp contrast in temperature, sharp contrast in dew point, signaled by a really dramatic wind direction shift as well. There are other ones that are even better. This is Norman, the famous city of Norman, Oklahoma. And so Norman has a really sharp frontal passage, a little bit later than it was at Mangum. Of course, that doesn't make, that's not surprising since it's further to the east. But look at that drop. Here, the temperature and dew point, it's just about saturated at the time the front comes by, and the temperature and dew point are right around 60. About 20 minutes later, I'm estimating, maybe 15 minutes later, the dew point and the temperature are around high 40s, maybe 45 degrees. And right at that moment, you can see that's when the wind goes from a steady southerly to a straight northerly. And here in the blue and the purple is wind speed, and gusts are in the light blue. So the wind speed dramatically increases as well, from something on the order of 5 knots from the south to suddenly, when the front comes by, 15, 20, 25, gusts well into the 30s at a couple of times right when this front comes through. So John, this is a really, yeah.
I was going to say, this is a really nice collection of meteorograms that you're showing. But
no, I'm not showing any meteorograms, but go ahead.
Yeah, it's really neat to see Also, the temperature and dew point traces kind of closing in on one another as the front approaches. It probably suggested that there's precipitation occurring, or there's maybe rain, cooled air, saturated air that's approaching the station ahead of the funnel passage.
That's a good point. And I took the top half of the Mesonet time series. They give you two other ones, precipitation, accumulated precipitation, and one other variable. I can't remember what it is now. I just took the top two for the presentation, but you can go back to the Mesonet site and see that. You're right. That's exactly what was happening here at Norman. So I have a couple more to go. Here's Wyona. So now we will have gone from Mangum to Norman to Wyona, a triumvirate of stations right across the central sort of part of Oklahoma. And here's what Wyona looks like. Again, a very classical frontal passage. And this one's about an hour later too, because it's further to the east, but the exact same characteristics. Straight southerly wind turning straight to the northwest, and then northerly right at the frontal passage with it. That's characterized by about 15-degree temperature drop. And then notice also the abrupt increase in wind speed. All these things are really nicely coincident. So beautiful features here in some of these stations in Oklahoma. Now, if you go to a place like Antlers, further to the north, to the south and east, the frontal passage is many hours later, and it's not quite as classical. It has a couple of different pieces to it, and I think that's because in this part of the state, you're near the Ouachita Mountains, and there's a little bit of orography. And so the orography plays a role, I think, in creating some of these mesoscale changes in the temperature. And you notice the wind direction is a little bit less obviously straight from south to north. There's a whole bunch of interaction going on as this front, at whatever structure it has when it goes through Antlers, Oklahoma, and its topography starts to have a little bit different look. Here's Fairview, Oklahoma, well to the north and west of Norman. Not as obviously a classical structure, I'd say, right? You're a lot warmer. Mid-afternoon yesterday, it's almost 75 degrees. Then there's a gradual but persistent drop for the next 6 or 7 hours that gets you into about 40-degree range, punctuated by a stunning drop of dew point temperature, not in terms of its magnitude, but in terms of its rapidity compared to the temperature drop. So there's something not quite phased between the dew point and the temperature drop at Fairview, Oklahoma. And yet you do have the nice wind direction change, but absolutely no change in wind speed or gusts as you go through. So this is not quite as classical a passage. And then finally at Hooker, Oklahoma, well to the north and west in the Panhandle, even less classical structure and cooler because it never gets as warm. It's a little bit higher elevation station, but 50 degrees, then a gradual drop. Boy, you can't even call that really anything more than maybe just a change in the diurnal cycle. It's a little bit more abrupt than that. And the dew point hardly shows anything but a broad decrease. And there's nothing going on in the wind direction at all. It's from the north the whole time, and the wind speed and gusts are about the same.
So, John,
so it's really, yeah.
I'm sorry to interrupt. Could you go,
okay,
after you finish this thought, could you go back to the prior trace?
Yeah, I'm pretty much done with this thought that Hooker also doesn't have a classical structure. And then Fairview in that location is kind of transitioning to one that's not quite so classical.
Right. So I'm curious, any sense on what might be happening at Fairview with the temperature dew point, that spread remains pretty constant up until both of them drop off. The dew point drops off faster mornings at maybe the northern edge of some sort of dry line. And then it seems like the relative humidity actually decreases after that wind shift. And then things begin to approach saturation as things cool off and moisten up a little bit, or not moisten up. The relative humidity begins to go up. But it's just a curious trace. Is it a developing front, perhaps?
I don't know. This would be the first place that I'd go. I'd want to look at stations in this location because I have a suspicion, just like what you said. I have a suspicion that you have sort of a lee side trough dry line feature that comes through the western part of the state. And it begins to take a little bit more classical cold frontal characteristics on the further east it gets. Magnum is the only station that doesn't fit that categorization that I've kind of developed quickly this morning in my head. But this looks like one of those cases where you have the abrupt dew point drop is a function of the lee side trough really behaving like a dry line. But it's also, the lee side trough is also going to be at the point of the maximum troughiness is going to be the point of the maximum temperature. So they go hand in hand as well. And I wonder if that isn't part of what's going on here. And the atmosphere in the immediate lee of the higher terrain to the west sometimes struggles to shed the influence of the high terrain on the on the thermal and moisture characteristics of the lower part of the troposphere. And I think we might be catching it in the act here with this particular site. And there's quite a number of them around Fairview that look relatively similar. So I think there's something interesting going on. And note the time. It's at a different time in the evolution of this whole structure too. We're catching it not only at a spot, but at a spot in time. And you can see how the whole structure may evolve in time as the cold air that's actually to the west catches up with the troughiness that may have initially been instigated by lee-side warming and hydrostatic pressure falls. So I'm not sure that isn't the case, but I can't say that it is. And then the last thing I want to say before I turn it over to Michael is that today is the 46th anniversary of the super outbreak of April 3rd, 1974. And I was looking around trying to find some nice analyses for this, and sure enough, Steve Corfidi and a bunch of authors, including his wife, Sarah, who was a graduate of our program, did a paper in 2010 in weather analysis and forecasting that kind of took a new look at the outbreaks. I'm just going to give you 2 or 3 maps from this analysis that they did. This is their subjective analysis of the 250 millibar winds, 12Z on the 3rd of April, 1974. Remember, the super outbreak was 148 tornadoes during the day, late afternoon of this day, across the Ohio River Valley and a little bit south of that and a little bit north of that. 13 different states were visited by tornadoes. Some of them were on the ground for an hour. Xenia, Ohio was destroyed by its visit with a tornado, so it was really quite dramatic. Fujita really did a lot of work on this outbreak to kind of work on his scale of damage and all the rest, so quite a dramatic event. It's still the most prolific tornado outbreak of all time. So on 12Z on the 3rd of April, 1904, there's an extraordinary, most likely combined subtropical and polar jet coming in across the California coast, 150, maybe even 160 knots offshore. Very dramatic. The area of interest is well downstream, and we're looking at maybe a difference in 12 hours or so upstream of the development of the outbreak. So it's a very intense upper jet, and not too much jet activity to the east. So this is really the feature of interest. The thing that really caught my eye was, I hadn't known this before, this is the 500 millibar map that they redrew. So the black lines are geopotential height lines, and then the red lines are isotherms every 2 degrees, and you have for some reason the -20 and the -30 isotherm, maybe just to give you an idea of the gradient, are in blue. So associated with that feature coming in off the California coast is a really remarkable upper level front. Look at the contrast in temperature between southern Oregon, 29 degrees, and 13 just north of Los Angeles. So that gradient is something on the order of 15-ish degrees Celsius across quite a small distance. And that's a really remarkable upper front. And notice the shear across it too. It's 105 knots near San Francisco, 95 near LA, 40 at Reno. You've got extraordinary horizontal shear, most likely geostrophic cold advection, well, certainly geostrophic cold advection. Look at the geopotential height lines. And so there's a tremendous tropopause fold associated with this event. But once that rounds the base of the trough, well, the temperature advection begins to change a little bit, and you suddenly have forcing for strong ascent. And that's not evident on this map at this moment, but I have a feeling that's what happened later in the day as maybe the middle tropospheric contribution to the forcing that might have led to this outbreak. But this is a really extraordinary upper level front. Reminds me of the October 2010 storm in some ways, in terms of what the 500 millibar analysis looks like, especially on this southern upper front portion of it. So really very dramatic, very strongly forced environment in this case, in an environment that had ripened over a series of days before it got to this point, quite likely. So a really interesting event. And then here's the surface map at the same time, and these are dew point contours, 65, 60, and 55 at 3 different thresholds. And I'm not sure what the 1 and the B mean, but anyway, here's a weak cyclone sitting over, well, not so weak, 984 sitting over eastern Kansas, and a really complex spider-like array of surface boundaries, whether or not they're actually cold fronts or not. This paper references a couple of things that I was enjoyed being involved in as a graduate student with respect to non-classical structure of storms as they emerge off the Rockies. And so I was kind of intrigued. I didn't read the whole paper today, but I have a feeling some of these structures were some of the ones that we found in our cold frontogenesis aloft work in the late 80s and early 90s with Peter Hobbs and John Locatelli. So this could well have been a lee side trough first, that got filled in with some cold air behind it. This is an Arctic front because it's still early April. So there's all manner of features, kind of, it's a mix. It's like a tossed salad of ingredients over the Central Plains at this time of year. And once in a while, some big organizing feature like a strong upper front comes along and organizes it in spite of the fact that it wants to stay unorganized. And that, I think, has something to do with the outbreak on this day. So I'm really intrigued. I want to read the paper again, but I want to highlight today, since it's the anniversary of this phenomenal event, and it turns out it had a couple of really striking synoptic features associated with it that are well worth the time to do subsequent investigation. So that's all I have. I think I'll give back the screen to Michael if there's no questions.
Thank you, John. Now I'm going to share.
I have a question real quick for anyone who might have the answer. And this is Ketzel, by the way. I don't know if my name comes up, but I was texted by a friend last night who was wondering if the decrease in magnitude of airplane flights is going to severely impact how many weather obs we have, and if that's going to be impacting our forecasting skill at all.
Yeah, that's a great question, Ketzel.
Excellent.
I know that's a subject of a number of discussions. I think ECWF has done a study. I don't know the exact results, but I believe there has been some evidence that there's been a degradation. I mean, aircraft observations are a useful observation in the sense that they can use them as airplanes take off and land at various airports all around the world. They can serve as a source of soundings, basically, sort of extra soundings that can be ingested into forecast models. This would certainly have been a much bigger issue a couple decades ago, but with the increased satellite coverage, I think that helps somewhat. But still, getting the vertical structure of the atmosphere as an additional set of observations improves our knowledge of the the thermal structure of the atmosphere, and to the extent we might be able to tease out winds from that as well, the vertical wind structure at a given several locations. So there's probably an impact. I think the studies are ongoing, but I think next Weather Watch, I'll see if I can find that study and at least give you a summary of what some of the key findings have been thus far. But it's certainly a topic of considerable interest in our community. I don't know if someone else has something to add to that.
This is Greg. I know that back when he was live, Reed Bryson studied the effect of the contrails over the Atlantic from airplanes flying back and forth to Europe. And he had felt, I think he published this somewhere, that the contrails were blocking enough sunlight to delay the phytoplankton bloom in the North Atlantic by a month. So that may be different this year. We may have more, or a further north, I guess it would be, or earlier bloom of phytoplankton, which is a bottom of the food chain. It helps fish. So there may be some differences in the ocean. So that's all I had to type in.
Okay. Yeah, thanks for the question. That was a great one, and thanks for the response, Greg. So first of all, we're going to start off with just looking at a map of the upcoming hazards forecast by the National Weather Service over the next 24 hours or so. As you can see, over the central part of the United States, as indicated by some of the observations that John showed us just earlier, there is some winter weather occurring from southeastern Kansas all the way up to the U.S.-Canadian border near International Falls. And that's a winter weather advisory. So the possibility of sleet and freezing rain exists in these regions ahead of that front that was briefly described. Also, out along in the western part of the United States, I guess just the California Sierras in northern California, they have a winter storm watch. I guess there might be a cyclone that will be impacting that region of the country. Also some winter weather up in western Montana. And then finally, in the eastern part of the United States, along coastal portions of Massachusetts, there are wind advisories and high wind warnings in those regions, as well as further to the south in the Delaware Bay, coastal flood watch with the strong winds blowing offshore. I guess there's a potential for some flooding along coastal regions of Delaware and southern New Jersey. So in general, it's a fairly quiet and a flood warning along some of the rivers in the central part of the United States as our spring melt begins, and we get lots of water, melting snow and everything feeding into rivers and tributaries of the Mississippi and other rivers to our south. So we're transitioning to spring clearly, but still some winter weather occurring over us. But the weather over the continental United States over the next day or so is going to be relatively quiet, I think. And so this will be a very somewhat abbreviated discussion of the weather for today. First of all, go to the pivotal weather, and we can see from this forecast, this is a forecast valid 18Z, so 1 o'clock this afternoon, shows the areas of frozen precipitation as forecast by the GFS pretty much over for parts of eastern Kansas, but freezing and frozen precipitation from across parts of central Iowa all the way into the western part of our state, just past Minneapolis, and then into the northeastern tip of the northeastern and east central Minnesota. They're expecting to get some frozen precipitation. Ahead of that front, liquid precipitation is expected, and we have relatively warm thicknesses all the way up to our latitude at this point. The intense cyclone that was referred to by John earlier, just off the east coast of the United States, shows up fairly well with really strong pressure gradient, and that's sort of indicative of the strong winds that we would expect associated with it. But again, the main feature in the weather is this frontal zone, and we saw some evidence of it at the surface and in the charts, the superpeats that John was just showing us. We're going to do a cross-section very briefly through that to sort of see where the frontogenesis is as we move forward in time. 6 hours later, so this is this evening, that front is beginning to approach. Again, some icing associated with it. That's kind of a curious feature with that really sharp drop-off in temperature. We saw some evidence of the sharp drop-off in the mesonet observations that John was showing. But basically liquid precipitation for us. Again, this is just ahead of the front, just before the front actually pulls through our area. And you can see the winds at this point have shifted to the north of the western part of our state, and we're still sort of in a weak wind region, but about to shift to the northwest in just a moment. So the peak of the heating and the peak of the warming is going to be probably around 3 or 4 o'clock before we begin to see things beginning to cool off, and column moistens, we might get some showery precipitation. Going into this evening, front continues through, but precipitation begins to weaken. All the frozen precipitation is well to our north, and we have a large anticyclone beginning to build in for the weekend. And so it looks like after a cloudy and sort of it's really unpleasant day, this will be nice to get out early this afternoon. We're going to turn cooler in the afternoon and early evening, and then tomorrow looks like it's going to set up to be a pretty nice day as the anticyclone begins to build over our area and the winds are northwesterly. So a much cooler patterns expected. And I'll just jump ahead 30 hours to tomorrow afternoon. You see this weak high over us. It's still an anticyclone over us, northerly winds with some cold advection. This is going to be a pretty cool period. If we go back, let's say to just around the time the front's expected to go through. So this is 0Z this evening, 7 p.m. It may have already gone through it by this time period. We can first look at the temperatures forecast by the model. This is the GFS. And what I'm going to do is I'm going to zoom in to a more regional view so you can see this. And if there are questions or features you want to see, please put your hand up or out. So you can see by this evening, by 0Z, we've already dropped to 40 degrees, just to give you a sense of we are. This is going to be pretty, 59, close to 60 right now in our area. This is the GFS explicit forecast. The surface temperatures or the output from the model unperturbed, but by the time we get to 7 p.m., we're already down to 40 degrees. So a big drop in temperature is expected, as I said, during mid to late afternoon when that front goes through. So the front will definitely be through by then. We can check out the winds at this point. Here, 10-meter winds. You can see we're already northwesterly. You can see the southerly winds and southeasterly winds that were pretty prevalent over parts of Oklahoma yesterday, just before the front came through and they had the abrupt wind shift. We're seeing a slightly different change in wind direction. As opposed to being more northerly, we're going to be more northwesterly. But you can see with the passage of the trough over us, we're going to get westerly winds, and temperatures are going to cool off. You can see that it's a little bit breezy behind this front as well. If you were to do a cross-section through this front, and I'll go back to just the time in which the front is expected to go through. This is a cross-section using some tropical tidbits. This is from the 12Z run of model. This is at 18Z this afternoon. I tried to get it somewhat perpendicular to the frontal zone at this point. And you can see at the very surface, you can see that this is theta E that's plotted here. There's certainly a pretty conspicuous theta E gradient at the surface. There's frontogenesis along the leading edge of that. There is some ascent ahead of it, which is not too surprising, but also kind of curious is the stratification. This is theta E in the vertical. Now, we're not saturated, so we can't make some explicit statements, but theta E is relatively constant with height, so it's a pretty moist, neutral atmosphere in the middle to upper troposphere, which I thought was kind of curious. But along the edge of this front, the leading edge of the cold advection, you can see frontogenesis well established along it. Now this cross-section, we're near the middle of the cross-section, so this is at the surface, the front's probably just by us at this point, but we still have this region of ascent that slopes back beyond the surface frontal position, and so that gives us the chance for some precipitation. Again, this theta E is pretty constant. It's increasing with height generally, but sort of weak stratification over us in terms of theta E. And you can see behind the front, stratification increases pretty markedly after that. And we'll go ahead.
Those are great cross sections. Yeah.
Yeah. Is anything about the theta E's constancy with height that strikes you as somewhat odd this time of year?
Well, one of the things that's interesting about this whole synoptic environment is that this front is right almost precisely on that really microscale ridge axis. Or it's just to the west of that ridge axis. And so the ridge axis is going to be characterized by relatively high theta E or high theta at upper levels. And if you have a narrow distance between it and the front, you're going to have this kind of axis of maximum theta E. It almost looks occluded, even though you know it's not. And that's the result is the poor stratification in the region of the updraft of the frontogenetic engine. So that's quite curious. Yeah,
I'd agree. So then the boundary itself slides past us by this evening, and now this is tomorrow morning. You can see again, this is not well set up in terms of cross section. Showers are beyond us, and we're clearly in a much cooler, at least theta E regime. Theta E is dropped off over us. If we're to look at sort of relative humidity in omega, not too useful to look at relative humidity at this stage, as we've certainly cooled off, but you can see that the water vapor, the largest value of water vapor now well to our east. There's some moisture trapped in the boundary layer, but this is maybe more of a function of the fact that the surface has cooled off a lot and it's dry aloft. So it looks like pretty decent weather coming in for the day tomorrow with it as the anticyclone builds in. So nice frontal passage, but if we go ahead to tomorrow, zoomed in, I'll go to 36 hours tomorrow evening. Anticyclone is again still building in over us, but with weak northerly winds. Again, a fairly quiet weather pattern over us. We'll go ahead to Sunday morning. Just want to quickly get through this sequence of maps. The ridge is now, just to the north of Green Bay. Weak winds at the surface. Let's actually plot those winds so you can see that. See a little pressure. East-northeasterly winds at the surface. And I imagine even though it might be a nice day, it'll be chilly. Temperatures during the day on Sunday are going to be cool. And if you're anywhere along the lake, Milwaukee or along, Oregon, those areas with an easterly flow, probably even chillier in those regions. Over the weekend, you can kind of see that indicated here with temperature staying in the 30s. This is in the morning, but if we go into the afternoon, again, we may just get close to 50 degrees, but along the eastern shore of the western shore of Lake Michigan, it's going to be pretty chilly. Temperatures in the low 40s. So not the nicest of weekends, but still dry, so that's not so bad. Sunday morning, or Monday morning, excuse me, at 12Z already in the low 40s, so that pretends to be a pretty decent day on getting back into the 50s, and just looking at the sea level pressure. Ridge is now to our east, and there's some showers that are beginning to creep up with warm advection now beginning to set up. I'll back out a little bit just so you can get a sense of the overall picture. We're also going to see dew points, at least in the mid part of the week, approaching the low 60s of our area. That's going to be another feature that sort of shows that it would clearly back into sort of more spring regime. Lots of showers in the southeastern United States. Again, the dew point temperatures in the 50s on Tuesday, or Monday night into Tuesday, and we watch them climb even further.
Wow, look at that.
Right, so we finally get into kind of almost, not summer type dew points, but sort of late spring type dew points in the low 60s. So this is going to be a pretty moist
Wow.
period. That's Tuesday evening, and at the surface, again, we have a cyclone going by, and so there's going to be showers and maybe some convective weather as that weather system goes by. You can see the trough right over us, the cyclone, a weak cyclone, just on the north central part of our state. I'm going to just quickly go through a couple clicks to go forward. This is a pretty quiet pattern. The showers go by, then we get into a cold advection regime. This is on Wednesday into Thursday, and it gets even colder. So it looks like we're heading toward kind of back, slowing down our progression into a nice spring-like weather. But that's somewhat short-lived. By the time we get to next week, we're going to be talking about cold air beginning to build in central, western and central Canada, if this forecast is to be believed. And just to give you a hint of what's, a week and a half out, what might be happening, temperature tumbling back into sort of a more, about a month back, sort of back into March type temperatures with cold advection. But I want to show you, this is a curious pattern. It might deal somewhat or be somewhat related to Ketzel's question. Look at just the difference in the forecast between the 0Z and the 12Z forecast.
Wow.
The forecast initialized 12 hours differently. Instead of having strong cold advection, we're still in a neutral to warm temperature advection regime. Same forecast time. If we go back to the 6Z run, there's some evidence of maybe cold, strong cold air building up to our west, but it's not the same forecast. And so there are some differences in going back a day. Same model, different initial conditions, suggesting cold air dumping in here. So I think the medium to extended range is still a little bit uncertain in terms of the forecast over our part of our neck of the woods.
Really interesting because this would be the time of year where it maybe is most sensitive to error anyway. And then if you throw in the fact that we're taking fewer obs almost surely, it's just going to be really crazy maybe. This is good evidence of that.
Right. Yeah, I don't want to say that this is definitely due to an observation issue, but it's certainly not going to be helped when you see this uncertainty in the forecast. You might ask, well, what about other forecast, other models? You look at ECWF. This is from 12Z yesterday. Unfortunately, we don't have the same set of pictures. Let me actually go to just 500 millibar heights and vorticity, since that's a pretty stable thing. So this was the 240-hour forecast from yesterday. If we look at the 0Z forecast, difference in flow, difference in timing with those waves, and then you go to the 12Z forecast from this morning. We're not far enough out, I guess, to get that. But so really, at that 7 to 10 day period, there is some increasing uncertainty in the forecast. To finish things off, again, the weekend showers this evening and abruptly turning chilly by sunset. Certainly before sunset, it's going to turn chilly with some showers. I don't think we'll see any convective or any thunder. We're not going to hear any thunder or see lightning with that. But then a few showers, cooler. The weekend looks increasingly better in terms of more sunshine during the day tomorrow, but cooler. Temperatures just struggling to get out of the 40s here, and upper 30s to low 40s along around Lake Michigan. And then Sunday warmer into the mid 50s again, and warming up a bit and getting more moist into early next week with some light, maybe even convective showers. If we look at the longer term forecasts, the CPC outlooks, for temperatures 6 to 10 days, even though we see some uncertainty in the GFS perhaps, it seems like the consensus forecast is for below normal through 6 to 10 days, and then even greater certainty 8 to 14 days, so cooling off. Precipitation-wise, maybe a slight chance of being above normal precip-wise, and then those chances, again, stay modest, I guess, for about 33% chance will be above normal precipitation. So again, the coloring on these extended range outlooks doesn't mean this is going to be very, very wet down here. It just means greater chance it'll be wet. And if I misspoke about the temperatures, it just seems like there's greater certainty or greater likelihood it will be colder than normal over the northern part of the United States. to 14-day range than it was forecast to be, let's say in the 6 to 10-day period. So that's just something to watch out for. So we're going to struggle, it looks like, to move toward a more summer sort of footing in terms of how the weather is going to manifest itself. But no big storms, at least in sight, over the the central plains and upper Midwest in the next week. So, Greg, I don't know if I think you had some maps you wanted to talk a little bit about the polar night jet and some of that.
No, I wasn't going to present anything. I was just showing you there.
Okay.
It's if anybody wants to know, it's mostly dissipated, but maybe in support of what you just said, the way it dissipated in this 12Z run from today is so much more than it dissipated in the 6Z run. So it's interesting that, maybe they're losing some handle on it. It's there, it's not there, it's there. It's just dissipating, but it does seem to change from one forecast to the next. So there's just a lot of uncertainty right now.
Okay. All right, let me stop sharing. And I guess that'll be it, I guess, for Weather Watch today. Have a nice weekend. Stay safe and stay well. Thanks, Pete, for setting this up. And thanks, John, for a really great presentation of the current weather. And Greg, your comments about the structure of the polar night jet. Everyone have a wonderful weekend.
Yeah, thanks everybody for attending, and thanks Michael and Pete and Greg, and we'll see you all next week.
You bet. Sounds good. I will grab the recording of this and post it on the AOS YouTube channel if anybody wants to go back and review anything or pass it on to your friends or whatever. Have a good weekend, everybody.
You
Thanks.
too, Pete. See you later.
John, I wish I could say, hey, you want to go get lunch?
I know, no kidding.
So.
Well, I don't know when we're going to be able to have our Mott and Morgan dinner on the deck, but as soon as we can, we're going to have to do it.
Okay. All right. Well, hey, stay well and have a wonderful weekend.
Yeah, you too, Michael. We'll see you.
All right. See ya. All right, Elizabeth.